We're the main guys behind the Sipcapture project and Homer, which has been just mentioned. Now we're bringing you a little bit of an update in terms of the application, the integration with OpenSIPS, and everything else. So yeah, since we're late, we're going to go just as quick as possible. So a quick introduction. GXIP is our company, actually based here in Amsterdam. We do R&D. We mostly work after the Homer project and all of the accessories of the project. So integration with everything else and so on and so forth. And we also do offer services to companies that deploy our software and use it in production. So if you need assistance, this is where you go to reach us. A little bit about centralized capture systems, which is what we are really talking about today. For those who already know, just allow for everybody else to catch up. Basically, a centralized capture system, as Bogdan also mentioned before, is a place where you can sort of concentrate and mirror all of your signaling, statistics, logs, whatever you work with. It's a centralized place where you can do your correlation and your search the easy way. For voice, this is never too easy, mostly thanks to vendors and stuff, but here we see a little bit of the key benefits and the user benefits, and we'll see how our system attempts to satisfy those. So yeah, it's all about Homer today, as per other times, and the Sipcapture stack. So we slowly are growing into a little bit of an ecosystem, so to support Homer being a good collector and having access to all of the information that it needs to have access to make sense. For you guys using it, we need to continuously extend our support and integration with the platforms that we actually want to monitor. So signaling and SIP is, of course, the baseline of everything, but it doesn't stop there. So what we did over the last year is really extend the platform to be able to deal also with, first of all, RTCP, that's where we started, then we extended RTCP XR, then custom reports, and then we started looking at logs, and then harvesting specific platform details, as we'll see here. But the point is still the same, getting all of your information, or as much as your information, in the same place, correlated in a way that makes sense for your troubleshooting, investigation, monitoring, forecasting, whatever you need to do with it. And of course, make it readily available to share with the people that you have to work with. So you can troubleshoot it yourself, but eventually you're going to have to show somebody what's happening. So that's what the Sipcapture stack is all about. And if you want a VoIP time machine, where you can go back and find whatever you missed, or go and demonstrate what you need to. And some of the other advantages, of course, are related to your investment. So what you actually use or sell on top of your platform is services, and those services need to be, of course, reliable. And when they're not, you need to know, who should be addressed, or if you got to get a discount from your peers, then you got to demonstrate that it happened. And this is also one of the aspects that we do cover. Another important one is that we are vendor agnostic. So with our platform, it really doesn't matter what you're using. Today we'll be talking a lot about OpenSIPS, but it's really designed to just ingest and digest whatever you throw at it. And if it doesn't support it yet, get in touch with us and it will. So the two main components of our solution are the capture server and the capture agent. The capture server, as you can already imagine, is the collector part. So that's where all of your packets are going to be received. They're going to be, of course, dissected, indexed, and statistics are going to be created. We support a bunch of types right now. So you can, of course, send SIP signaling, but you can also send app reports with JSON payloads, with statistics, and we'll see how you can do that. On the other side of the line, you have the capture agents, and it's almost always going to be Explorer, especially with the latest direction that we're going. We're trying to split them or have mini agents for micro tasks that are easy to take and integrate with existing solutions, or to recycle existing data, because this is really the purpose of it. You already have many times the data that you need to do the troubleshooting. You just have it all over the place, and we don't want to recapture and reproduce what you already have. So the direction that we're going is, if you have anything in any of your systems that you can use and correlate to what we do in Homer, that's what we want you to be able to do. Oh, sorry. So that's really the direction, and you'll see how we try to achieve that. But you can already foresee the scope of where this is going. And talking about the capture agent, the capture server, sorry guys, it's a pretty big moment. So from exactly now on, you can build the capture server with either OpenSIPS or Camillo with exactly equal starting point. So both are able to handle the backend functionality of Homer. Both are able to handle all these special app types. And in, as of the current situation, OpenSIPS has some lead advantage because it's able to also do some other nice cool things that will be presented tomorrow by John in the other presentation dedicated to the improvements that the team, that our teams together achieve in terms of Sipcapture. So those are the two leading platforms. As you can see, there's an additional functionality in the OpenSIPS side, which is app switching, and exactly what will be presented next. We can take a quick look, and here Alexandr is the lead. Maybe
okay, it's here. It's only 2 words about app switching. It's additional advanced functionality of app in OpenSIPS, and exactly it was developed by OpenSIPS team. Before, Camillo and OpenSIPS only can get or receive the HEP message and only extract payload type and do nothing. Yeah, so insert the database and make only zip parsing. Since now you can able to get any parameter of HEP message, extract any types of chunks, also not only extract but also set parameters, and make a retransmission of this HEP message to next call. So it means OpenSIPS can work not only like collector but also like a proxy server. Here is exactly example of event socket. Before it goes to main route of OpenSIPS zip parsing, you can exactly make some manipulation with HEP message and discard or insert report. Most report or with quality reports direct to database without parsing or pre-parsing the message in mine HEP row.
And exactly here you can see the HEP type is expressed, so 100, 32, 33. You will see those and many more coming, so as many types as we define and as many as you will be able to support. But in this case, having it directly in the configuration makes it extremely easy to extend and prototype over also new things.
Exactly. If you would like to send some additional reports, you should not. You should only add additional block inside of event socket, and it will be immediately inside the database, and it doesn't matter which type of database you look at.
Correct. And this might sound more complicated than it is. So at this current stage of HEP, there is all the pieces of the puzzle are on our repository. So you can literally go take the bare bones of the HEP protocol, define a new type, send it into OpenSIPS, and basically make your own support, your own customization. And similarly on the capture.
Yeah, exactly here. Now you can define exactly proto-HEP type of transport. It can be not only UDP, but it also has support for TCP, stream protocols. And now, okay, before, to duplicate zip message in HEP, you just need to call zip trace function for each message. Now we have functionality what you can call by dialogues. So only if you have dialogues not loaded up before up, you just call once the zip trace function, and all messages related to this dialog will be automatically duplicated to Homer server.
And we're talking a lot about HEP or EEP. So this is a breakdown of what the protocol does for those who don't know, just to make sure we're on the same page. So HEP starts as the Homer encapsulation protocol. Today it's EEP, extensible encapsulation protocol. This is how it's going to be landing, but we keep code names not to confuse everybody too much in the process. But what it does, it's really, you know what encapsulation is all about. What's special about HEP is that the latest version has the concept of chunks. So it's really easy to implement within the protocol without changing its specification. To define additional data types, which can be platform specific. So, you know, OpenSIPS can have its own, FreeSwitch can have its own, Asterisk can have its own, and they can stream inside of the standard format custom information with backwards compatibility. So, you know,
so on demand you can define your additional chunk and put some information which is related only for your project or for your platform, and it will be immediately inserted to database and can be displayed web interface.
And currently, as we said, we have types for SIP, XMTP, RTCP, RTCP-XR. We have our own HSP MOS format. We can accept custom logs, CDRs, plain text, or JSON string. So, you know, you can use it as a starting point to go a lot of places. Now, how you get it started? We, in the early release days of Homer 5, installing was quite a mess, not to use another word. We spent a lot of time trying to make it easier. Today, we're back to the good old days where we have an install script, which works for Debian and CentOS-based OSs, and it basically sets everything up for you. So you just run it, there's minimal interaction, you just have to choose basically the database credentials, and it brings up a fully working Homer system with either Camellia or OpenSIPS. You can choose. We're having both scripts now available. And yeah, it does most of the work for you. Of course, it doesn't do any optimization of the database, so you know the resourcing and stuff is still quite important and something that you can definitely understand from the other documentation on our website. If you like Docker, you can also very, very easily bring up a fully working Docker container or multi-container. So we did also quite a lot of work, and we had some nice contributions for this site. It literally takes maybe 3-4 minutes to bring it up and running, and it has everything built in. So against you know the Homer school, we also have a container which carries MySQL, Camellia, or OpenSIPS, and the web server all in one block. So ideal if you want to just try it out, send some traffic, see if it works for you, and then deal with it later on. We don't have it here, but we also have a Puppet version available in the repository. If that's your thing, it's fully working. Once you have it up and running, we'll make it super brief here. The new interface of Homer is actually designed to be more of a framework where you can design and create your own widgets. So there's a few default things, but unlike the older Homer, you are in full control. So you can define what's there. Once you define your statistics, your charts, you just set them in place. You create as many panels or dashboards as you want, and off you go. Same goes for the form widgets, which are actually widgets. Many people don't realize it, but those are programmable. So all of those fields, all of those options are dynamic. You can change them, make your own. If your team only tends to use you know, certain headers, make it easy for them. Build a form which does exactly what they need, and yeah, they're going to get
buttons are also dynamic, yeah? So you can add additional
all buttons. You can have a search dashboard for tier 1, tier 2, tier 3 with growing complexity. Just, you know, it's designed to make the life of the user more comfortable. So you can make it as good as you want to make it. And in terms of results, everything is similar, but we're doing continuous improvements to the display part. So today, besides the call flow, we also display QoS reports, logs, and all of that. So the more data you throw into Homer, the more data you can see correlated. But we won't spam you too much with that. The wiki is nowadays pretty good shape, so you can go there, and it basically works as our main documentation tree. So it's on our GitHub repository, github.com/Sipcapture Homer wiki, and you'll find everything. And this is updated on a daily basis. So if there's an experiment, if there's a hack something, you'll find it here. And anything that we present tends to have a dedicated page somewhere. So now about feeding Homer, which is the most important part. So once you have the collector up and running, of course you got to throw something at the system or it's going to be totally useless. How do we do that? We do it by providing, as far as we can, native agents inside as many platforms as we can support. Luckily, we have a pretty good click with the community in general, and we tend to be happy to do the dirty work when we can. So we don't expect people just to do it for us, but we actually enjoy interaction and cooperation on that front. This is what we have achieved so far. So OpenSIPS and Camellia, as you know, can be used for both capture server or capture agent. So they're the glue of the project. On top, of course, we have everything else. So free switch, asterisk. We implemented support also for RTP engine, which is very popular, and nowadays can also become capture agent itself, and you can send RTCP packets straight back to Homer. SIP grep, SN grep, and then more importantly, maybe we do have code snippets for the languages that you can see here on our repository. So if you have a project you want to give HEP a go, you want to see if it works for you, it's literally a matter of copy pasting a few code blocks, and you have a prototype up and running. As we have seen, it's very easy to create your own types. So again, we're going in the direction where we want people to be comfortable experimenting with HEP, not just using it in production. And this is a little bit of a breakdown in terms of what we support today and how we use it. So on the left side, you see the voice systems and projects that we do support, what we use them for. Mostly it's capturing CPAR, TCP, and RTP. On the other side, it's everything else. So nowadays, you have APIs, you have backends, you have non-voice elements of your voice flow, and this is how we begin to bring those into Homer. And it's easier than anything to correlate. So as long as you have a correlation ID or something that you can use to glue them together, the front application does the rest. We already seen here before a few mentions of how to use OpenSIPS 2.2 and the new features for Capture Agent. We're not going to spend a lot of time because tomorrow is going to be a workshop with John where we'll go full depth, and I think it's going to be much more juicy in terms of this, but just as a reference, we have it in our presentation. And this is a breakdown a little bit how it works. We've made a cross here between the two servers, but just to show you how the capture flows are going. So from user to user, you can see the protocols and how we capture them and flow them into Homer, and what systems we use. So free switch is also has been a big point of development lately. Alexandr can give us an update here, but starting from 168, and you will see 17 somewhere here. It's a mistake. 168, which is a
it was a surprise for us, because we expected in 1.7, but this was integrated in 1.68.
Exactly. Our contribution was for 1.7, but the team, I guess, liked it enough, and they did the backport into 1.68. So latest version of free switch on their repository supports what you see here. What we did is literally the same as product platforms. We're keeping the HEP ecosystem up to par. So as of now, FreeSwitch supports HEP3 or EEP with all of the features. So you can
HEP2
HEP2 as well. That's right. HEP2, 1, 2, and 3 actually. They're
all family.
All the full family. The main difference from going from HEP1 to the higher versions is that it retains the local timestamp and additional information about the packet. So with HEP1, the timestamp is just the network one. From HEP2 up to HEP3 and EEP, it's defined by the system. So it's time accuracy of the system where you're capturing it. You can see here, it's very easy to enable it in FreeSwitch. You just activate the capture server parameter in your Sophia configuration, and on the internal or external or whatever profile you have, you can just enable it permanently or by session. And this is a little bit another breakdown how it works. What's new is that we have implemented also what we call an external capture agent or a log harvester in HEP, which attaches to the FreeSwitch ESL library. Oh, sorry, it's still here. What we do is we run a Node.js agent which attaches to ESL, and it looks for data that it can use in Homer. So what we do right now is we mirror all of the standard channel events, so you will know what the channel is doing directly in the logs. So as you open a session, you will see signaling, statistics, and in the log part, you will see exactly what FreeSwitch was doing. But what we managed to do is we also extracted the media statistics from FreeSwitch, and we turned them into a pseudo RTCP version. So we take whatever FreeSwitch does know about the media handling, and we flow it to Homer as a standard report. So what it does, it generates full chart, MOS score, jitter, whatever we can take out of the system, flow it back, and you have it. And
only small notice, because you see it's MOS 4.5. It's internal calculation of MOS by FreeSwitch.
Yeah, FreeSwitch has its own way of measuring quality, which is, it's not the same the rest of the world uses, but it's still useful. It's only an internal, so it doesn't express much about the networking. It's more about the internal quality of the handling of the call. But still, we use it, and Homer is anyway able to determine its own MOS. So depending on the information that you provide back to a session, if we have jitter, packet loss, whatever, we do make our own estimation. So we take all of the information we have and we try to globalize a score, and then of course you can go packet to packet. And this is a little bit how it works. So we have the normal SIP and RTP flow into FreeSwitch. The SIP part is mirrored, as you have seen, with the built-in capture agent. And everything else we take from ESL. So directly into EPI, you can use anything else you want, but EPI, ESL is ready to the SIPs and RTP engine, doing the same. So what you end up having here is an end-to-end visibility over not only the signaling or signaling conversion, but also the quality between your endpoints. The same really goes for Asterisk. So at this point, the two platforms are quite similar on that level. The difference is that in Asterisk, we do physically mirror each and every RTCP packet that we receive. This is something that's possible also in FreeSwitch, but it might be overkill with the ESL integration, so the community will decide. But in Asterisk, as said, we have a standard capture agent. You can mirror everything you want directly, 4 parameters, and you're done.
It's very important that Asterisk only works with PGZ.
PGZ only, yes. This is something that,
okay, we have version 10.11, yeah, which works with standard Asterisk zip stack, but since version 13, it's
an hybrid. What we advise if you're going to go this way is to start with a fresh stack and a PGZ version. Just because it works great and it's supported directly by the team. This was more of the Asterisk project decision to support it this way, not ours. So, we respect it and we go with it. And once again, this is how it works. So Asterisk is able to mirror all of its traffic, including RTCP. And the result is very simple. You have end-to-end visibility in Homer. And this is a little bit how the RTCP to JSON report actually looks like. So this is a sender report where you have timestamp, the octets, and everything else that we use to make statistics. As you see here, there is no MOS. But Homer is going to be able to produce one when...
So it's normal serialization of FTCP in JSON. Same FTP agent will send.
Yes, exactly the same that we have in also Cap agent. WSS. So maybe Alexandr here you can...
yeah, okay. So you have also WebSocket inside of OpenSIPS, and you can extract some information from OpenSIPS and write this information to logs, or send it to exactly to Homer. So it's I could not I will not say too much because it's exactly HTTP headers, which will help you to understand who sends, which browser sends this message, and so on, so on, so on. So it's just additional information to website.
Yeah, it's basically correlated information in terms of
which transport.
That's
zip JavaScript zip client used.
Yeah, so before it becomes SIP, and you also have information related to the key exchange and everything else, so this can be very precious to troubleshoot complex scenarios. This is a little bit how it's going to look when you activate it. So for a WSS session to SIP, you would see the logs in terms of how this was generated on the HTTP socket side. Last but not least, you can also use it for monitoring a remote device or user agent. So we did this actually at prototype level with the JSSIP client. So we just basically forked the debug log of the JSSIP application, and we started sending it to the collector with correlation. So you can also extend it and see what the client was actually doing at the time. Of course, this is a feature which might turn out to be very expensive and complex. So, we sort of consider it, a plugin option that you can use for custom cases, or maybe as a triggerable activation.
If you remember, we exactly found the bug after we activated this login.
Yeah, it was for the great Fosden talk. Thanks, Saul, for inviting us there. And if you don't have any of the above and you still need to capture, there's CapAgent. CapAgent is currently at version 6.1. It gets better and better in terms of memory consumption and resource utilization. It's right now pretty solid. We have it in quite intensive live environments, and it's holding up. What CapAgent does is basically take over what your platform cannot. So if for any reason you're running an older version of FreeSwitch, Asterisk, or anything else, or you do not want to mix, which is fully legit, your production settings with your monitoring part. So if you want a fully passive approach, Capt agent is exactly designed to do this. So it's a universal modular capture agent which can do all of the above. So everything that you have seen so far, including the RTC reporting, logging, everything else, can basically be done by Capt agent, and this is what we try to do. So it's the leading app and EEP integrated platform, and this is where we also develop whatever is coming and we validate it. So anything that's available in those capture agents on platform, you will also find to some extent in Capt agent 6. The way it works, it has changed. So Capt agent 4 was a pretty standard single file configuration, and it was maybe over complex for a single file. So what we did is we migrated to sort of a mix of legacy configuration, cascading configuration from other platforms. So many of you will recognize some styling here. But what you can do is basically define cascading config. So in this example, we see the most simple configuration of Capt agent that you can possibly have. So socket pcap is basically defining how you're going to be capturing packets. So here we just define the interface any, no reassembly, no Dubovikov, and we define a capture plan, which is exactly in this case for Sipcapture plan, CFG, and a port range. What this does, it takes this socket, and anything that comes into the socket gets processed by the specific capture plan. So you can see on the other side, what the capture plan does is basically piping data from the socket, making a bunch of checks. So now it's not just simply take the packet and carry it, but you can actually go look at the packet, look at the source, divide it. So you can, to some extent, do also balancing. You can send a specific setup traffic to a specific Homer instance, or you can just drop what you don't want, and so on and so forth. So what Alexandr did here is he made it basically fully programmable. So you can go into big depths.
Yeah, so it's sort of programming language, and here you can make some manipulation of zip message. You can exactly define to which destination you would like to send, and which type you would like to send. For example, here is send cap. So it means you will send in encapsulation protocol. You can also define and send a zip message in JSON if you would like to collect all zip messages inside of Elasticsearch or InfluxDB or whatever. You can send it like JSON, and it will be inserted to any databases. And exactly here, you can also define to extract some SDP information and do dialog takings exactly for TCP mirroring. So you can define it's drawing.
Yeah, you can say that the lower part, which is grayed out, actually defines a second capture plan, which is only for RTCP. So we have a second interface, we have a second port range, and whatever comes into this range is going to be processed by the dedicated
so in zip part, you extract exactly SDP information, TCP port. And in second part, in the TCP capture plan, you exactly check if this source destination IP exists in our cache table. We make exactly JSON serialization of TCP packet and send to Homer and collect this information in database.
Simple as that, but it can also be used just simply, for limiting your traffic, or if you run into an issue, you want to isolate something.
Yeah, you can also extend and add additional parameters.
It's fully programmable. Break it, send us reports and bugs, and we can wait for people to use it to make it actually better. If you don't want any of the above and you just want to keep it super simple, there's Sipgraph and SNGraph. Sipgraph and SNGraph are quite standard tools, and if you don't have either one on a system, then you probably don't use it for VoIP. Both are equipped with app and EP support as of their latest versions. So Sipgraph 2 and SNGraph 1 can both have, as you see here in the example, direct mirroring to our instance. Actually use very similar code for that. And what it does, it just simply allows you to turn your real-time session, so you're figuring something out on the console, but then it's gone. This way you can actually keep it without necessarily grabbing the pcap. You can just mirror it to your instance and have somebody else remotely investigate it, or just help you with it, or keep it for later. We also have an RTP analyzer. Time is running low, so I'm just keep it super quick. Yeah. Okay, good. So this RTP agent is a special version or a commercial extension of Capt agent. which also is a display of its flexibility as a capture framework to create more complex things. What it does, similar to what we do with SIP and RTCP, we can also do with RTP. So RTP agent basically has a dedicated pipeline for RTP packets. It can do the same thing. So we can analyze all of those packets, we can correlate them to their SIP session. But what it does that's cooler than the rest is that it tries to do this in a privacy-friendly manner. So we do not decode any of the conversation to do the score. So we just don't get our nose into the actual speech. We just do everything by determination based on the awareness of course, the codec, the rate, and the network performance. So, yeah, exactly. Fully taking advantage of everything that we know about the session. We do our own estimation, and what this agent can actually do is send a report time. So you can decide, I want to report every 15 seconds, 30 seconds, 40 seconds, whatever your network requires. And what it does this way is provide granularity, because many times you end up with those long calls, 1 hour, 2 hours, and you have a single score, MOS 3. What does it mean? How was it determined? And this way, you basically have a running MOS. So every X seconds, minutes, you have a new MOS score, and you're able to see exactly how the quality of the call was over even a long duration. So even if there was a 5-second glitch somewhere in the middle of it, you're going to be able to find it, and you're going to be able to interface with the customer or the peering partner.
And also you have automatic detection if you have MOS down. It will be sent with checks periodically, often. Yeah?
That's the cool thing, is that the rate can also be self-adjusted to report, so it's programmable to a certain extent to be able to exactly give you real-time feeding when things are going down or going south, and you want to be alerted, not just in Homer, but also by other means. So this is what the agent is dedicated for. It's fully supported in Homer. So it actually provides the most advanced type of report that Homer supports so far. It's not just about quality and packets, it's also about everything else that we did. So here's an example of HepPipe, which is one of our node utilities that you can just attach to any data source, really. This is an example with a syslog line that we want to correlate to a SIP session. So here we have a platform which is logging some internal information, or maybe directly from one of its components into a syslog that you don't have access to from a network perspective, so it only exists on the system. That's certainly their call, but you want to see it in Homer. And this is what HepPipe comes in for. So you can just basically point it at a specific log. You can give it a regex filter, which is used for matching and correlation. And you can just use everything to build your own custom HEP report that you can send to the platform. This is an open example, so literally you can go in and change it to do whatever you want it to be doing. As long as you have a correlation ID that brings it back to the SIP session, you're good to go. The way it works just has to be seen very simple. You just pull it down, place it on the system, or in a place where it has access to the logs that you want to be looking at. You define the example row, how to extract it, and that's really it. It uses type 100. And it sends directly to Homer. And what we mentioned before for ESL is actually built on a fork of the same tool. So we have a specialized version of HepPipe, which instead of looking at log lines, it just is able to connect via also using node to FreeSwitch ESL event socket. And as we described before, it can react to any event. So you can literally program it as the example comes with a bunch of initial examples. But what it looks like at the end is something like this. So once you correlate some data into your Homer instance, you open a session, you go into log stamps, and it's there. So it's a pre-filtered subversion of whatever your system were doing. And of course, you can also have a local filter. This tab can end up having, of course, hundreds or thousands of rows in some cases. So there's a local search functionality there to filter it out. A few notes about sharing. So everything is cool. Your guys have access to Homer within the company, but now all of a sudden you got to send this PCAP, or you got to give somebody else access to this, and it's a mess. You don't want to give them a password. They don't have access to your system. So we have a couple of options built into Homer. The first one is the share link functionality that you will find in the export tab. What this does, it basically takes a snapshot of whatever you're looking at, with a completely separate ID, so there is no correlation to the initial event. There is no search functionality. It's just a snapshot with a unique link that is going to be accessible on the same server where you're running Homer, or on a separate one if you deploy that element of the interface. So you can have an edge, let's say, read-only interface to Homer, where your operators can share data that they want somebody else to have access to. And what it looks like is, as you see in the corner, it's like a minified or simplified version of everything that you would see when you open a session. So call flow, RTC media reports, if any, logs, and re-export functionality if they want to send it to PCAP. If this is not possible, so if you have external parties that you really don't trust, or you don't want to deploy this web server, or you just want to keep Homer safe, we do have cloud share functionality. Our main integration right now is with CloudShark, just because we have a really good relationship with the project. We've been actually the first one to integrate with CloudShark when it came out, and we're still keeping it up to speed. So at any point, with just a few lines of configuration, you can share whatever you have in Homer with CloudShark. And this would be completely external. We will run on their cloud, so you can just share that link with anybody, and they will have absolutely no idea even where it came from or that Homer generated. To activate it is just really a couple of lines, your API key and the URL. And as we said, this is designed for CloudShark, but it's literally compatible with just about any API. It's just making an upload with an authentication key. So this potentially can work with a bunch of
Dropbox or Google Drive.
Anything you want. It's really, really easy to extend. As per many other things in Homer and on the repository, they're meant to be examples that are ready to be extended. For everything else, there's the Homer API. So unlike previous versions, Homer 5 is really API-based. So Homer itself is now a big API, and everything that you can do from the user interface is available via API functions and calls. So consider our user interface an integration on top of the Homer API, but this can be very easily done from anywhere else. So if you have an existing customer portal and you want to implement some of our features for your customers, you basically do it by the API. You just inspect the console, see how we do it, copy it out, and so on and so forth. The same way, via the API, we do also now provide SNMP functionality. So we do have a proxy for those who are really old school and really want to do it that way. There is a bridge, and it works right, and as per everything else, it's ready to extend. And this sort of concludes the update. So, as I said, all of our features, we try to keep them updated on the wiki and on GitHub. So everything that we discussed, if there is an example. If there's not an example, let us know. We'll make one. Any questions?
Exactly time.
Yeah, we have 3 minutes for a question.
No,
2.
Did you export it to a PCAP file?
Yes, absolutely. At all stages, you can export to PCAP, to text format, and yeah, that's it. That's the stuff.
Can you capture the RTP traffic?
Yes, you can, if you have the agent that supports it. So the standard capture agent does not even look at RTP. It looks at RTCP and SIP. If you need to do RTP recording, that we have this.
Can it play decent?
Yes, you can. But as we said, we're privacy friendly, so we do not dip into the codec unless you want to. That's like a separate additional functionality on top. We are able to produce statistics, MOS, and metrics for basically all codecs.
Also including SFTP.
It stores
Yes.
the files in the local file system, or
Sorry?
it stores it in the local file system?
It's stored where the probe is running, and it can be, of course, streamed and fetched by.
Or you can also store it in database or file system.
It's as per many other things in CapTage, it is modules, so that's the option.
Last year didn't have RTP.
No, this is brand new. We had RTCP statistics, but the real RTP capability comes now. It's pretty recent. So
It's
as
on
of
the
now,
beta stage.
yeah, as of now, Homer can fully handle media if you wanted to, but not necessarily. You can do still everything without.
It can also be used like LI.
Yes, exactly. We have lawful interception as well.
Does it take a lot of performance?
Depending how many sessions you throw at it, yes.
It depends on how many
Yes,
CPU you
it's
can.
designed to run on a dedicated system. So we expect, if you do RTP, we expect you to dedicate it. Yeah. Or you can break it down into smaller systems, and you can also, of course, it's a software element, so it can also be run exclusively on the system, but the capacity there becomes quite tedious.
That's exactly what good answer was on media proxy web page.
Yeah.
It can handle one session.
Yes, but it's passive monitoring, so we don't expect people to actually deploy this on the critical systems. We always expect them to have both options and decide whatever works.
Do you support clustered models across the capture servers so you can
Yes.
deploy different data centers?
Yeah, absolutely, and that's a little bit of the logic also in the capture agents. It's you're expected to have multiple Homer systems. Each system can search itself and any other system. So you can also cluster them and cross-connect them. So you can have many Homer instances, even if they're not database connected. They can search. Right. So it's like a hypervisor, which can connect to many Homer instances. And of course, at Homer level, it's database connectivity. So you can scale the database any way you want. We just connect to it.
So do I lose anything by using capture agent instead of doing it
Not really, no. Generally speaking, no. Unless you're looking for something that's not transmitted on the network at all.
Usually we're using a VoIP monitor.
Yeah. Yeah, well, that's a completely different approach because that platform records everything to do its job. We try to do the opposite. We try to record nothing, do everything in transit if we can, and keep it streamlined. So we only want to stream back the reports and not double your capacity and requirements in terms of storage, especially because that doesn't make any sense.
Exactly. Our goal is to make a calculation before you know you have a problem. Yeah?
That's right.
Make
So
notification.
for us, recording the RTP is a matter of special things. It's either LI or you need to do a special test with the customer. For everything else, we think we do cover 100% using statistics, and this is what we also promote because it's lightweight and it's very easy to keep up and running.
Yeah.
Anybody else?
Well, so far it's clear.
Well, then thank you for your time, guys. It's been a pleasure.
Thank you, Alexandr. Up next, we've got Giovanni. He's going to be talking about free switch load balancing and high availability. And while I have everyone's attention, do we have any vegetarians in the room? Please raise your hand. You won't be persecuted, I promise. Okay, so we're good there.